this time, Nishal, the calculator, looked over the minutes of their passage and worked out figures with unparalleled dexterity. Mitchell Arden chatted first with Barbicane, who did not answer him, and then with Nishal, who did not hear him, with Diana, who understood none of his theories, and lastly with himself, questioning and answering, going and coming, busy with 1,000 details. At one time bent over the lower glass, at another roosting in the heights of the projectile, and always singing. In this microcosm, he represented French loquacity and excitability, and we beg you to believe that they were well represented. The day, or rather, for the expression is not correct, the lapse of 12 hours, which forms a day upon the earth, closed with a plentiful supper carefully prepared. No accident of any nature had yet happened to shake the travelers' confidence, so, full of hope, already sure of success, they slept peacefully, while the projectile, under an uniformly decreasing speed, was crossing the sky. Chapter 4. A little algebra. The night passed without incident. The word night, however, is scarcely applicable. The position of the projectile with regard to the sun did not change. Astronomically, it was daylight on the lower part and night on the upper, so when during this narrative these words are used, they represent the lapse of time between rising and setting of the sun upon the earth. The traveler's sleep was rendered more peaceful by the projectile's excessive speed, for it seemed absolutely motionless. Not a motion betrayed its onward course through space. The rate of progress, however rapid it might be, cannot produce any sensible effect on the human frame when it takes place in a vacuum, or when the mass of air circulates with the body which is carried with it. What inhabitant of the earth perceives its speed, which, however, is at the rate of 68,000 miles per hour? Motion under such conditions is felt no more than repose, and when a body is in repose, it will remain so as long as no strange force displaces it. If moving, it will not stop unless an obstacle comes in its way. This indifference to motion or repose is called inertia. Barbicane and his companions might have believed themselves perfectly stationary, being shut up in the projectile. Indeed, the effect would have been the same if they had been on the outside of it. Had it not been for the moon, which was increasing above them, they might have sworn that they were floating in complete stagnation. That morning, the 3rd of December, the travelers were awakened by a joyous but unexpected noise. It was the crowing of a cock which sounded through the car. Mitchell Arden, who was the first on his feet, climbed to the top of the projectile and, shutting a box, the lid of which was partly open, said in a low voice, "Will you hold your tongue? That creature will spoil my design." But Nishal and Barbicane were awake. "A cock," said Nishal. "Why no, my friends," Mitchell answered quickly. "It was I who wished to awake you by this rural sound." So saying, he gave vent to a splendid cock-a-doodle-doo, which would have done honor to the proudest of poultry yards. The two Americans could not help laughing. "Fine talent that," said Nishal, looking suspiciously at his companion. "Yes," said Mitchell, "a joke in my country. It is very Gallic. They play the cock so in the best society." Then turning the conversation. "Barbicane, do you know what I have been thinking of all night?" "No," answered the president. "Of our Cambridge friends. You have already remarked that I am an ignoramus in mathematical subjects, and it is impossible for me to find out how the savants of the observatory were able to calculate what initiatory speed the projectile ought to have on leaving the Columbiad in order to attain the moon." "You mean to say," replied Barbicane, "to attain that neutral point where the terrestrial and lunar attractions are equal. For starting from that point, situated about 9/10 of the distance traveled over, the projectile would simply fall upon the moon on account of its weight." "So be it," said Mitchell, "but once more, how could they calculate the initiatory speed?" "Nothing can be easier," replied Barbicane. "And you knew how to make that calculation?" asked Mitchell Arden. "Perfectly. Nishal and I would have made it if the observatory had not saved us the trouble." "Very well, old Barbicane," replied Mitchell. "They might have cut off my head, beginning at my feet, before they could have made me solve that problem." "Because you do not know algebra," answered Barbicane quietly. Ah, there you are, you eaters of X1. You think you have said all when you have said algebra. Mitchell, said Barbicane, can you use a forge without a hammer or a plow without a plowshare? Hardly. Well, algebra is a tool, like the plow or the hammer, and a good tool to those who know how to use it. Seriously. Quite seriously. And can you use that tool in my presence? If it will interest you. And show me how they calculated the initiatory speed of our car. Yes, my worthy friend, taking into consideration all the elements of the problem, the distance from the center of the Earth to the center of the Moon, of the radius of the Earth, of its bulk, and of the bulk of the Moon, I can tell exactly what ought to be the initiatory speed of the projectile, and that by a simple formula. Let us see. You shall see it, only I shall not give you the real course drawn by the projectile between the Moon and the Earth in considering their motion round the Sun. No, I shall consider these two orbs as perfectly motionless, which will answer all our purpose. And why? Because it will be trying to solve the problem called the problem of the three bodies, for which the integral calculus is not yet far enough advanced. Then, said Mitchell Arden, in his sly tone, mathematics have not said their last word. Certainly not, replied Barbicane. Well, perhaps the Selenites have carried the integral calculus farther than you have. And by the by, what is this integral calculus? It is a calculation, the converse of the differential, replied Barbicane seriously. Much obliged, it is all very clear, no doubt. And now, continued Barbicane, a slip of paper and a bit of pencil, and before a half-hour is over, I will have found the required formula. Half an hour had not elapsed before Barbicane, raising his head, showed Mitchell Arden a page covered with algebraical signs, in which the general formula for the solution was contained. Well, and does Nishal understand what that means? Of course, Mitchell, replied the captain. All these signs, which seem cabalistic to you, form the plainest, the clearest, and the most logical language to those who know how to read it. And you pretend, Nishal, asked Mitchell, that by means of these hieroglyphics, more incomprehensible than the Egyptian ibis, you can find what initiatory speed it was necessary to give the projectile. Incontestably, replied Nishal, and even by this same formula, I can always tell you its speed at any point of its transit. On your word. On my word. Then you are as cunning as our president. No, Mitchell, the difficult part is what Barbicane has done, that is, to get an equation which shall satisfy all the conditions of the problem. The remainder is only a question of arithmetic, requiring merely the knowledge of the four rules. That is something, replied Mitchell Arden, who for his life could not do addition right, and who defined the rule as a Chinese puzzle, which allowed one to obtain all sorts of totals. The expression v0, which you see in that equation, is the speed which the projectile will have on leaving the atmosphere. Just so, said Nishal, it is from that point that we must calculate the velocity, since we know already that the velocity at departure was exactly 1.5 times more than on leaving the atmosphere. I understand no more, said Mitchell. It is a very simple calculation, said Barbicane. Not as simple as I am, retorted Mitchell. That means that when our projectile reached the limits of the terrestrial atmosphere, it had already lost 1/3 of its initiatory speed. As much as that? Yes, my friend, merely by friction against the atmospheric strata. You understand that the faster it goes, the more resistance it meets with from the air. That I admit, answered Mitchell, and I understand it, although your X's and 0's and algebraic formula are rattling in my head like nails in a bag. First effects of algebra, replied Barbicane, and now, to finish, we are going to prove the given number of these different expressions, that is, work out their value. Finish me, replied Mitchell. Barbicane took the paper and began to make his calculations with great rapidity. Nishal looked over and greedily read the work as it proceeded. That's it, at last he cried. Is it clear? Asked Barbicane. It is written in letters of fire, said Nishal. Wonderful fellows, muttered Arden. Do you understand it at last? Asked Barbicane. Do I understand it? Cried Arden. My head is splitting with it. And now, said Nishal, to find out the speed of the projectile when it leaves the atmosphere, we have only to calculate that. The captain, as a practical man equal to all difficulties, began to write with frightful rapidity. Divisions and multiplications grew under his fingers. The figures were like hail on the white page. Barbicane watched him, while Mitchell Arden nursed a growing headache with both hands. Very well, asked Barbicane after some minutes' silence. Well, replied Nishal, every calculation made V0, that is to say, the speed necessary for the projectile on leaving the atmosphere to enable it to reach the equal point of attraction, ought to be. Yes, said Barbicane. 12,000 yards. What? Exclaimed Barbicane, starting. You say 12,000 yards. The devil, cried the president, making a gesture of despair. What is the matter? Asked Mitchell Arden, much surprised. What is the matter? Why, if at this moment our speed had already diminished 1/3 by friction, the initiatory speed ought to have been 17,000 yards. And the Cambridge Observatory declared that 12,000 yards was enough at starting, and our projectile, which only started with that speed. Well, asked Nishal. Well, it will not be enough. Good. We shall not be able to reach the neutral point. The deuce. We shall not even get halfway. In the name of the projectile, exclaimed Mitchell Arden, jumping as if it was already on the point of striking the terrestrial globe. And we shall fall back upon the earth. Chapter 5. The Cold of Space. This revelation came like a thunderbolt. Who could have expected such an error in calculation? Barbicane would not believe it. Nishal revised his figures. They were exact. As to the formula which had determined them, they could not suspect its truth. It was evident that an initiatory velocity of 17,000 yards in the first second was necessary to enable them to reach the neutral point. The three friends looked at each other silently. There was no thought of breakfast. Barbicane, with clenched teeth, knitted brows and hands clasped convulsively, was watching through the window. Nishal had crossed his arms and was examining his calculations. Mitchell Arden was muttering. That is just like these scientific men. They never do anything else. I would give 20 pistoles if we could fall upon the Cambridge Observatory and crush it, together with the whole lot of dabblers in figures which it contains. Suddenly a thought struck the captain, which he at once communicated to Barbicane. Ah, said he, it is 7 o'clock in the morning. We have already been gone 32 hours. More than half our passage is over, and we are not falling that I am aware of. Barbicane did not answer, but after a rapid glance at the captain, took a pair of compasses wherewith to measure the angular distance of the terrestrial globe. Then from the lower window he took an exact observation, and noticed that the projectile was apparently stationary. Then rising and wiping his forehead, on which large drops of perspiration were standing, he put some figures on paper. Nishal understood that the president was deducting from the terrestrial diameter the projectile's distance from the earth. He watched him anxiously. No, exclaimed Barbicane after some moments, no, we are not falling. No, we are already more than 50,000 leagues from the earth. We have passed the point at which the projectile would have stopped if its speed had only been 12,000 yards at starting. We are still going up. That is evident, replied Nishal, and we must conclude that our initial speed, under the power of the 400,000 pounds of gun cotton, must have exceeded the required 0 yards. Now I can understand how, after 13 minutes only, we met the second satellite. which gravitates round the Earth at more than 2,000 leagues distance. And this explanation is the more probable, added Barbicane, because, in throwing off the water enclosed between its partition breaks, the projectile found itself lightened of a considerable weight. Just so, said Nishal. Ah, my brave Nishal, we are saved. Very well then, said Mitchell Arden quietly, as we are safe, let us have breakfast. Nishal was not mistaken. The initial speed had been, very fortunately, much above that estimated by the Cambridge Observatory, but the Cambridge Observatory had nevertheless made a mistake. The travelers, recovered from this false alarm, breakfasted merrily. If they ate a good deal, they talked more. Their confidence was greater after than before the incident of the algebra. Why should we not succeed? Said Mitchell Arden. Why should we not arrive safely? We are launched. We have no obstacle before us, no stones in the way. The road is open, more so than that of a ship battling with the sea, more open than that of a balloon battling with the wind. And if a ship can reach its destination, a balloon go where it pleases, why cannot our projectile attain its end and aim? It will attain it, said Barbicane. If only to do honor to the Americans, added Mitchell Arden, the only people who could bring such an enterprise to a happy termination, and the only one which could produce a President Barbicane. Ah, now we are no longer uneasy. I begin to think, what will become of us? We shall get right royally weary. Barbicane and Nishal made a gesture of denial. But I have provided for the contingency, my friends, replied Mitchell. You have only to speak, and I have chess, draughts, cards, and dominoes at your disposal. Nothing is wanting but a billiard table. What? Exclaimed Barbicane. You brought away such trifles. Certainly, replied Mitchell, and not only to distract ourselves, but also with the laudable intention of endowing the Selenites' smoking divans with them. My friend, said Barbicane, if the moon is inhabited, its inhabitants must have appeared some thousands of years before those of the earth, for we cannot doubt that their star is much older than ours. If then these Selenites have existed there hundreds of thousands of years, and if their brain is of the same organization of the human brain, they have already invented all that we have invented, and even what we may invent in future ages. They have nothing to learn from us, and we have everything to learn from them. What? Said Mitchell. You believe that they have artists like Phidias, Michelangelo, or Raphael? Yes. Poets like Homer, Virgil, Milton, Lamartine, and Hugo. I am sure of it. Philosophers like Plato, Aristotle, Descartes, Kant. I have no doubt of it. Scientific men like Archimedes, Euclid, Pascal, Newton. I could swear it. Comic writers like Arnold and photographers like Nader. Certainly. Then, friend Barbicane, if they are as strong as we are, and even stronger, these Selenites, why have they not tried to communicate with the Earth? Why have they not launched a lunar projectile to our terrestrial regions? Who told you that they have never done so? Said Barbicane seriously. Indeed, added Nishal, it would be easier for them than for us, for two reasons. First, because the attraction on the moon's surface is 6 times less than on that of the Earth, which would allow a projectile to rise more easily. Secondly, because it would be enough to send such a projectile only at 8,000 legs instead of 80,000, which would require the force of projection to be 10 times less strong. Then, continued Mitchell, I repeat it, why have they not done it? And I repeat, said Barbicane, who told you that they have not done it? When? Thousands of years before man appeared on Earth. And the projectile, where is the projectile? I demand to see the projectile. My friend, replied Barbicane, the sea covers 5/6 of our globe. From that we may draw 5 good reasons for supposing that the lunar projectile, if ever launched, is now at the bottom of the Atlantic or the Pacific, unless it sped into some crevasse at that period when the crust of the Earth was not yet hardened. Old Barbicane, said Mitchell, you have an answer for everything, and I bow before your wisdom. But there is one hypothesis that would suit me better than all the others, which is the Selenites, being older than we, are wiser and have not invented gunpowder. At this moment, Diana joined in the conversation by a sonorous barking. She was asking for her breakfast. "Ah," said Mitchell Arden, "in our discussion we have forgotten Diana and Satellite." Immediately, a good-sized pie was given to the dog, which devoured it hungrily. "Do you see, Barbicane," said Mitchell, "we should have made a second Noah's Ark of this projectile, and borne with us to the moon a couple of every kind of domestic animal." "I dare say, but room would have failed us." "Oh," said Mitchell, "we might have squeezed a little." "The fact is," replied Nicholl, "that cows, bulls, and horses, and all ruminants, would have been very useful on the lunar continent, but unfortunately the car could neither have been made a stable nor a shed." "Well, we might have at least brought a donkey, only a little donkey, that courageous beast which old Silenus loved to mount. I love those old donkeys. They are the least favored animals in creation. They are not only beaten while alive, but even after they are dead." "How do you make that out?" asked Barbicane. "Why," said Mitchell, "they make their skins into drums." Barbicane and Nicholl could not help laughing at this ridiculous remark, but a cry from their merry companions stopped them. The latter was leaning over the spot where Satellite lay. He rose, saying, "My good Satellite is no longer ill." "Ah," said Nicholl. "No," answered Mitchell, "he is dead. There," added he in a piteous tone, "that is embarrassing. I much fear, my poor Diana, that you will leave no progeny in the lunar regions." Indeed, the unfortunate Satellite had not survived its wound. It was quite dead. Mitchell Arden looked at his friends with a rueful countenance. "One question presents itself," said Barbicane. "We cannot keep the dead body of this dog with us for the next 48 hours. "No, certainly not," replied Nicholl, "but our scuttles are fixed on hinges. They can be let down. We will open one and throw the body out into space." The president thought for some moments and then said, "Yes, we must do so, but at the same time taking very great precautions." "Why?" asked Mitchell. "For two reasons which you will understand," answered Barbicane. "The first relates to the air shut up in the projectile, and of which we must lose as little as possible." "But we manufacture the air." "Only in part. We make only the oxygen, my worthy Mitchell, and with regard to that, we must watch that the apparatus does not furnish the oxygen in too great a quantity, for an excess would bring us very serious physiological troubles. But if we make the oxygen, we do not make the azote, that medium which the lungs do not absorb, and which ought to remain intact, and that azote will escape rapidly through the open scuttles." "Oh, the time for throwing out poor Satellite," said Mitchell. "Agreed, but we must act quickly." "And the second reason?" asked Mitchell. "The second reason is that we must not let the outer cold, which is excessive, penetrate the projectile, or we shall be frozen to death." "But the sun?" "The sun warms our projectile, which absorbs its rays, but it does not warm the vacuum in which we are floating at this moment. Where there is no air, there is no more heat than diffused light, and the same with darkness. It is cold where the sun's rays do not strike direct. This temperature is only the temperature produced by the radiation of the stars, that is to say, what the terrestrial globe would undergo if the sun disappeared one day." "Which is not to be feared," replied Nicholl. "Who knows?" said Mitchell Arden. "But, in admitting that the sun does not go out, might it not happen that the earth might move away from it?" "There," said Barbicane, "there is Mitchell with his ideas." "And," continued Mitchell, "do we not know that in 1861 the earth passed through the tail of a comet, or let us suppose a comet whose power of attraction is greater than that of the sun? The terrestrial orbit will bend toward the wandering star, and the earth, becoming its satellite, will be drawn such a distance that the rays of the sun will have no action on its surface." "That might happen, indeed," replied Barbicane, "but the consequences of such a displacement need not be so formidable as you suppose." "And why not?" "Because the heat and cold would be equalized on our globe. It has been calculated that, had our Earth been carried along in its course by the comet of 1861, at its perihelion, that is, its nearest approach to the Sun, it would have undergone a heat 28,000 times greater than that of summer. But this heat, which is sufficient to evaporate the waters, would have formed a thick ring of cloud, which would have modified that excessive temperature, hence the compensation between the cold of the aphelion and the heat of the perihelion. At how many degrees, asked Nishal, is the temperature of the planetary spaces estimated? Formerly, replied Barbicane, it was greatly exaggerated, but now, after the calculations of Fourier of the French Academy of Science, it is not supposed to exceed degrees centigrade below zero. Pooh, said Mitchell, that's nothing. It is very much, replied Barbicane. The temperature which was observed in the polar regions at Melville Island and Fort Reliance, that is 76 degrees Fahrenheit below zero. If I mistake not, said Nishal, M. Pouillet, another savant, estimates the temperature of space at 250 degrees Fahrenheit below zero. We shall, however, be able to verify these calculations for ourselves. Not at present, because the solar rays, beating directly upon our thermometer, would give, on the contrary, a very high temperature. But when we arrive in the moon, during its 15 days of night at either face, we shall have leisure to make the experiment, for our satellite lies in a vacuum. What do you mean by a vacuum? Asked Mitchell. Is it perfectly such? It is absolutely void of air. And is the air replaced by nothing whatever? By the ether only, replied Barbicane. And pray, what is the ether? The ether, my friend, is an agglomeration of imponderable atoms, which, relatively to their dimensions, are as far removed from each other as the celestial bodies are in space. It is these atoms which, by their vibratory motion, produce both light and heat in the universe. They now proceeded to the burial of Satellite. They had merely to drop him into space, in the same way that sailors drop a body into the sea. But, as President Barbicane suggested, they must act quickly, so as to lose as little as possible of that air whose elasticity would rapidly have spread it into space. The bolts of the right scuttle, the opening of which measured about 12 inches across, were carefully drawn, while Mitchell, quite grieved, prepared to launch his dog into space. The glass, raised by a powerful lever, which enabled it to overcome the pressure of the inside air on the walls of the projectile, turned rapidly on its hinges, and Satellite was thrown out. Scarcely a particle of air could have escaped, and the operation was so successful that later on Barbicane did not fear to dispose of the rubbish which encumbered the car. Chapter 6. Question and Answer. On the 4th of December, when the travelers awoke after 54 hours' journey, the chronometer marked 5 o'clock of the terrestrial morning. In time, it was just over 5 hours and 40 minutes, half of that assigned to their sojourn in the projectile, but they had already accomplished nearly 7/10 of the way. This peculiarity was due to their regularly decreasing speed. Now when they observed the Earth through the lower window, it looked like nothing more than a dark spot, drowned in the solar rays. No more crescent, no more cloudy light. The next day, at midnight, the Earth would be new, at the very moment when the moon would be full. Above, the orb of night was nearing the line followed by the projectile, so as to meet it at the given hour. All around the black vault was studded with brilliant points, which seemed to move slowly, but at the great distance they were from them, their relative size did not seem to change. The sun and stars appeared exactly as they do to us upon Earth. As to the moon, she was considerably larger, but the travelers' glasses, not very powerful, did not allow them as yet to make any useful observations upon her surface or reconnoiter her topographically or geologically. Thus the time passed in never-ending conversations all about the moon. Each one brought forward his own contingent of particular facts, Barbicane and Nishal always serious, Mitchell Arden always enthusiastic. The projectile, its situation, its direction, incidents which might happen, the precautions necessitated by their fall on to the moon, were inexhaustible matters of conjecture. As they were breakfasting, a question of Mitchell's relating to the projectile provoked rather a curious answer from Barbicane, which is worth repeating. Mitchell, supposing it to be roughly stopped, while still under its formidable initial speed, wished to know what the consequences of the stoppage would have been. "But," said Barbicane, "I do not see how it could have been stopped." "But let us suppose so," said Mitchell. "It is an impossible supposition," said the practical Barbicane, "unless that impulsive force had failed, but even then its speed would diminish by degrees, and it would not have stopped suddenly." "Admit that it had struck a body in space." "What body?" "Why, that enormous meteor which we met." "Then," said Nicholl, "the projectile would have been broken into 1,000 pieces, and we with it." "More than that," replied Barbicane, "we should have been burned to death." "Burned!" exclaimed Mitchell. "By Jove, I am sorry it did not happen, just to see." "And you would have seen," replied Barbicane. "It is known now that heat is only a modification of motion. When water is warmed, that is to say, when heat is added to it, its particles are set in motion." "Well," said Mitchell, "that is an ingenious theory." "And a true one, my worthy friend, for it explains every phenomenon of caloric. Heat is but the motion of atoms, a simple oscillation of the particles of a body. When they apply the brake to a train, the train comes to a stop, but what becomes of the motion which it had previously possessed? It is transformed into heat, and the brake becomes hot. Why do they grease the axles of the wheels? To prevent their heating, because this heat would be generated by the motion which is thus lost by transformation." "Yes, I understand," replied Mitchell, "perfectly. For example, when I have run a long time, when I am swimming, when I am perspiring in large drops, why am I obliged to stop? Simply because my motion is changed into heat." Barbicane could not help smiling at Mitchell's reply. Then, returning to his theory, said, "Thus, in case of a shock, it would have been with our projectile as with a ball which falls in a burning state after having struck the metal plate. It is its motion which is turned into heat. Consequently, I affirm that, if our projectile had struck the meteor, its speed thus suddenly checked would have raised a heat great enough to turn it into vapor instantaneously." "Then," asked Nicholl, "what would happen if the Earth's motion were to stop suddenly?" "Her temperature would be raised to such a pitch," said Barbicane, "that she would be at once reduced to vapor." "Well," said Mitchell, "that is a way of ending the Earth which will greatly simplify things." "And if the Earth fell upon the sun?" asked Nicholl. "According to calculation," replied Barbicane, "the fall would develop a heat equal to that produced by 16,000 globes of coal, each equal in bulk to our terrestrial globe." "Good additional heat for the sun," replied Mitchell Arden, "of which the inhabitants of Uranus or Neptune would doubtless not complain. They must be perished with cold on their planets." "Thus, my friends," said Barbicane, "all motion suddenly stopped produces heat, and this theory allows us to infer that the heat of the solar disk is fed by a hail of meteors falling incessantly on its surface. They have even calculated—" "Oh dear," murmured Mitchell, "the figures are coming." "They have even calculated," continued the imperturbable Barbicane, "that the shock of each meteor on the sun ought to produce a heat equal to that of 4,000 masses of coal of an equal bulk." "And what is the solar heat?" asked Mitchell. "It is equal to that produced by the combustion of a stratum of coal surrounding the sun to a depth of 47 miles. And that heat would be able to boil 2,900,000,000 of cubic mariameters of water." "And it does not roast us," exclaimed Mitchell. "No," replied Barbicane, "because the terrestrial atmosphere absorbs 4/10 of the solar heat. Besides, the quantity of heat intercepted by the Earth is but a billionth part of the entire radiation." "I see that all is for the best," said Mitchell, "and that this atmosphere is a useful invention, for it not only allows us to breathe, but it prevents us from roasting." "Yes," said Nicholl, "unfortunately, it will not be the same in the moon." "Bah," said Mitchell, always hopeful. "If there are inhabitants, they must breathe. If there are no longer any, they must have left enough oxygen for 3 people, if only at the bottom of ravines, where its own weight will cause it to accumulate, and we will not climb the mountains, that is all." And Mitchell, rising, went to look at the lunar disk, which shone with intolerable brilliancy. "By Jove," said he, "it must be hot up there." "Without considering," replied Nishal, "that the day lasts 360 hours. And to compensate that," said Barbicane, "the nights have the same length, and as heat is restored by radiation, their temperature can only be that of the planetary space." "A pretty country that," exclaimed Mitchell. "Never mind, I wish I was there. Ah, my dear comrades, it will be rather curious to have the Earth for our moon, to see it rise on the horizon, to recognize the shape of its continents, and to say to oneself, 'There is America, there is Europe,' then to follow it when it is about to lose itself in the sun's rays. By the by, Barbicane, have the Selenites eclipses?" "Yes, eclipses of the sun," replied Barbicane, "when the centers of the three orbs are on a line, the Earth being in the middle. But they are only partial, during which the Earth, cast like a screen upon the solar disk, allows the greater portion to be seen." "And why," asked Nishal, "is there no total eclipse? Does not the cone of the shadow cast by the Earth extend beyond the moon?" "Yes, if we do not take into consideration the refraction produced by the terrestrial atmosphere. No, if we take that refraction into consideration. Thus let lowercase delta be the horizontal parallel and p the apparent semi-diameter." "Oh," said Mitchell, "do speak plainly, you man of algebra." "Very well," replied Barbicane. "In popular language, the mean distance from the moon to the Earth being 60 terrestrial radii, the length of the cone of the shadow, on account of refraction, is reduced to less than 42 radii. The result is that when there are eclipses, the moon finds itself beyond the cone of pure shadow, and that the sun sends her its rays, not only from its edges, but also from its center." "Then," said Mitchell, in a merry tone, "why are there eclipses when there ought not to be any?" "Simply because the solar rays are weakened by this refraction, and the atmosphere through which they pass extinguished the greater part of them." "That reason satisfies me," replied Mitchell. "Besides, we shall see when we get there. Now tell me, Barbicane, do you believe that the moon is an old comet?" "There's an idea." "Yes," replied Mitchell, with an amiable swagger, "I have a few ideas of that sort." "But that idea does not spring from Mitchell," answered Nishal. "Well then, I am a plagiarist." "No doubt about it. According to the ancients, the Arcadians pretend that their ancestors inhabited the Earth before the moon became her satellite. Starting from this fact, some scientific men have seen in the moon a comet whose orbit will one day bring it so near to the Earth that it will be held there by its attraction." "Is there any truth in this hypothesis?" asked Mitchell. "None whatever," said Barbicane, "and the proof is that the moon has preserved no trace of the gaseous envelope which always accompanies comets." "But," continued Nishal, "before becoming the Earth's satellite, could not the moon, when in her perihelion, pass so near the sun as by evaporation to get rid of all those gaseous substances?" "It is possible, friend Nishal, but not probable." "Why not?" "Because, faith, I do not know." "Ah," exclaimed Mitchell, "what hundred of volumes we might make of all that we do not know." "Ah, indeed, what time is it?" asked Barbicane. 3 o'clock, answered Nishal. "How time goes," said Mitchell, "in the conversation of scientific men such as we are. Certainly, I feel I know too much. I feel that I am becoming a well." Saying which, Mitchell hoisted himself to the roof of the projectile to observe the moon better, he pretended. During this time, his companions were watching through the lower glass. Nothing new to note. When Mitchell Arden came down, he went to the side scuttle, and suddenly they heard an exclamation of surprise. "What is it?" asked Barbicane. The president approached the window and saw a sort of flattened sack floating some yards from the projectile. This object seemed as motionless as the projectile and was consequently animated with the same ascending movement. "What is that machine?" continued Mitchell Arden. "Is it one of the bodies which our projectile keeps within its attraction and which will accompany it to the moon?" What astonishes me, said Nishal, is that the specific weight of the body, which is certainly less than that of the projectile, allows it to keep so perfectly on a level with it. Nishal, replied Barbicane, after a moment's reflection, I do not know what the object is, but I do know why it maintains our level. And why? Because we are floating in space, my dear captain, and in space bodies fall or move, which is the same thing with equal speed whatever be their weight or form. It is the air which by its resistance creates these differences in weight. When you create a vacuum in a tube, the objects you send through it, grains of dust or grains of lead, fall with the same rapidity. Here in space is the same cause and the same effect. Just so, said Nishal, and everything we throw out of the projectile will accompany it until it reaches the moon. Ah, fools that we are, exclaimed Mitchell. Why that expletive? Asked Barbicane. Because we might have filled the projectile with useful objects, books, instruments, tools, etc. We could have thrown them all out, and all would have followed in our train. But happy thought, why cannot we walk outside like the meteor? Why cannot we launch into space through the scuttle? What enjoyment it would be to feel oneself thus suspended in ether, more favored than the birds who must use their wings to keep themselves up. Granted, said Barbicane, but how to breathe? Hang the air to fail so inopportunely. But if it did not fail, Mitchell, your density being less than that of the projectile, you would soon be left behind. Then we must remain in our car. We must. Ah, exclaimed Mitchell in a loud voice. What is the matter? Asked Nishal. I know, I guess, what this pretended meteor is. It is no asteroid which is accompanying us. It is not a piece of a planet. What is it then? Asked Barbicane. It is our unfortunate dog. It is Diana's husband. Indeed, this deformed, unrecognizable object, reduced to nothing, was the body of Satellite, flattened like a bagpipe without wind, and ever mounting. Chapter 7. A moment of intoxication. Thus a phenomenon, curious but explicable, was happening under these strange conditions. Every object thrown from the projectile would follow the same course and never stop until it did. There was a subject for conversation which the whole evening could not exhaust. Besides, the excitement of the three travelers increased as they drew near the end of their journey. They expected unforeseen incidents and new phenomena, and nothing would have astonished them in the frame of mind they then were in. Their overexcited imagination went faster than the projectile, whose speed was evidently diminishing, though insensibly to themselves. But the moon grew larger to their eyes, and they fancied if they stretched out their hands they could seize it. The next day, the 5th of November, at 5 in the morning, all three were on foot. That day was to be the last of their journey, if all calculations were true. That very night, at 12 o'clock, in 18 hours, exactly at the full moon, they would reach its brilliant disk. The next midnight would see that journey ended, the most extraordinary of ancient or modern times. Thus, from the first of the morning, through the scuttles silvered by its rays, they saluted the orb of night with a confident and joyous hurrah. The moon was advancing majestically along the starry firmament. A few more degrees, and she would reach the exact point where her meeting with the projectile was to take place. According to his own observations, Barbicane reckoned that they would land on her northern hemisphere, where stretch immense plains and where mountains are rare. A favorable circumstance, if, as they thought, the lunar atmosphere was stored only in its depths. Besides, observed Mitchell Arden, a plain is easier to disembark upon than a mountain. A selenite, deposited in Europe on the summit of Mont Blanc, or in Asia on the top of the Himalayas, would not be quite in the right place. And added Captain Nishal, on a flat ground, the projectile will remain motionless when it has once touched, whereas on a declivity it would roll like an avalanche, and not being squirrels we should not come out safe and sound, so it is all for the best. Indeed, the success of the audacious attempt no longer appeared doubtful, but Barbicane was preoccupied with one thought, but not wishing to make his companions uneasy, he kept silence on this subject. The direction the projectile was taking toward the moon's northern hemisphere showed that her course had been slightly altered. The discharge, mathematically calculated, would carry the projectile to the very center of the lunar disk. If it did not land there, there must have been some deviation. What had caused it? Barbicane could neither imagine nor determine the importance of the deviation, for there were no points to go by. He hoped, however, that it would have no other result than that of bringing them nearer the upper border of the moon, a region more suitable for landing. Without imparting his uneasiness to his companions, Barbicane contented himself with constantly observing the moon, in order to see whether the course of the projectile would not be altered, for the situation would have been terrible if it failed in its aim, and being carried beyond the disk should be launched into interplanetary space. At that moment, the moon, instead of appearing flat like a disk, showed its convexity. If the sun's rays had struck it obliquely, the shadow thrown would have brought out the high mountains, which would have been clearly detached. The eye might have gazed into the crater's gaping abysses and followed the capricious fissures which wound through the immense plains. But all relief was as yet leveled in intense brilliancy. They could scarcely distinguish those large spots which give the moon the appearance of a human face.